graph of exponential functions. So let us make some graph of exponential functions. First, let me go with a standard one, say e to the x. You can go second ln, that gives you e, and then type there x and use the standard window. We go to zoom 6. So you can see this is the graph of e to the x. So it is actually going all the way like this. It doesn't cross x-axis. So this graph has a horizontal asymptote at y equals 0, which is x-axis. Now the y-intercept here is 1 because e to the 0 is 1. Now just check this. Go to trace. So 0 gives you 1. When you have 1, then it's just e, and we know that e is 2.71828 continued. Yeah, so we'll take some more examples and graph the function. Take another one. Type here, say 2 to the x. What happens? It's very similar to the previous one, but what is the difference? You will see when I put it e to the x. I'm going again second e to the x, and then see the graph. This one is more stiff because e is 2.71828, and this one we have taken 2 to the x. This one is going up. Now if I take, say, 3 to the x, so we are expecting that it will go here. Let me see. Third one, I'm taking 3 to the x. It should go inside further. See here, 7 to the x. And I want to reduce my window a little bit. So let me make it -5 to 5, and the y I put here maybe -1 to, say, 100. See what happens. So this is my 2 to the x, then going e to the x, then going 3 to the x, and then going 7 to the x. Further, we can say the domain of exponential function will be -infinity to +infinity, and the range will be 0 to infinity. We are taking one more example. F of x is 3 to the x. We just want to find some values of the function at those x values. So when x is -1, this is 3 to the -1, or you can just say 3 over e. You can leave it there. f0 will be 3 e to the 0, which is just 3. f1 will be 3 e to the 1. You can just say 3e. Now f3 will be 3 e to the 3. We just want to say a quick example. If I have some function involving exponential, how we find the domain of this function? So we have learned in chapter 1 that in the domain this must not be 0. So you just say 1 minus e to the x should not be equal to 0. That means e to the x should not be 1. Now the simple idea, if I say e to the x should not be 1, that means x should not be 0. It's a simple idea because e to the 0 is 1. So that's why we have our domain where x not equal 0. In interval notation, you can write -infinity to 0 and then 0 to infinity. I hope you understand this. Thank you.